All right, so we have three separate tables here. Okay, and what we want to do for each of these is we want to determine if the table represents a linear function. So our instructions are do the tables represent linear functions? Okay, to figure this out, what we want to do is we want to find the change in y, which is written by triangle y, over the change in x for each one. So if we look at our first table, which I'll call table A, I see that x is going up by 1 each time. Okay? And I see that y, let's see, is going up by 4, everywhere, right? So I can say that this is linear with a slope of 4 over 1. The y's change going up by 4 when x changes by 1. Now let's look at another one. For my x's, let's see, I'm going, how far away is negative 2 to 1? That is a distance of what? 3. So plus 3, and then plus 3 again, plus 3 again. All right, what's happening with my y's? Subtract 5, subtract 5, subtract 5, subtract 5. So I can say linear again with a slope of negative 5 over 3, meaning I would go down 5 units on y when I move over 3 units on x. Okay, and our last one. I see that x is going up by 12 and then by 10. So this one might be tricky. I have to be careful. And the corresponding y values go up by 6 and then by 5. So because they're not going up by the same amount, does that guarantee it's not linear? Well, not necessarily, because here's what we need to do. We need to find out, well, what is 6 over 12? Simplified, that's 1/2. Well, what's 5 over 10? Simplified, it's still 1/2. So because when you simplify the fractions to their simplest form, they're the same, you can again say they are linear.